Hi there. This video is on finding the determinant of a matrix using cofactors. Find the determinant by expanding along the first row of matrix C. Now, there's another video posted that goes over how to find minors and cofactors and how to actually find the determinant, but I wanted to do a couple examples, so let's start with this one. I'm going to expand this along the first row, so what that looks like then is here's my determinant of C equals. This is the process that I go through when I do this. I need to write down the first element, which is 1. Then I need to cross out that row and column and write the determinant with what's left. 3, 2, 4, and 5. Then I'm going to erase that and I'm going to write the next number down, which is 0. And I'm going to write the determinant that happens when I take my 0 and remove the row and the column that 0 is in, and I write down what's left. -7, 2, 8, and 5. Then I'm going to erase that. I'm going to write down the last element, which is a 3. And then I'm going to take out that row and column and write down the determinant that is a result, which is -7, 3, 8, 4. So now what I've written here are the minors that go along with these entries in my original matrix. But when you find the determinant, you need to use cofactors. Now what makes a cofactor different than a minor is this right here. When you multiply -1 to the power of the number of rows plus the number of columns, that is going to just affect the sign of the element. So what I've done here is I've written what it would look like for a 3x3, 4x4, and 5x5 matrix if you just enter this amount here. This is just going to change the sign from positive to negative. So what I like to do is just remember that this is a checkerboard pattern and it always starts with a plus in the upper left hand corner, and from there you can figure out the plus minus depending on the row or the column that you're on. So now let's go back, let's use that, and let's go back to that problem and put in our signs. Okay, so now let's take a look and use our knowledge of that checkerboard to figure out what the signs are. Since I'm going along the top row, and I told you that the top corner is always the plus, this is going to be plus, minus, plus. So then I just put my cofactor identifiers in these spots. Now it's just a matter of doing the calculation. So I've got 1, and now I need to multiply that times my determinant, which is 15 minus 8, that's 7. Then I've got -0 times this determinant, and it really doesn't matter what it is because I'm going to be multiplying by 0, but I'll go ahead and fill it in. -35 minus 16, which is -51. Then I have plus a -3, so I can just write -3 if I want, and then I need to multiply that times that last determinant, which is -28 minus 24, which is -52. So that gives me 7 minus 0 plus 156. So my determinant for this is 163. Okay, now here's that exact same matrix, and we're going to find the determinant by expanding along the first column of C. Here's my number 1, so I write that down. Then I cross out the row and column and write the determinant that I get with what's left. Then I move on to the second element, that's a -7, and I cross out that row and column and I make a determinant with the 4 items that are left. Then I'm going to look at the third one, this is the 8, and then take out that row and column and make a determinant out of what's left, and that's what goes here. Next, I need to take a look at what my cofactor signs would be based on that checkerboard. So if this spot is a plus, then this one's a minus, and this one's a plus. So I'm going to come down to my problem and I'm going to put a plus here, here's the minus, and here's the plus. And now when I calculate those all out, I end up with 15 minus 8, which is 7, 0 minus a negative 12, which is 12, and 0 minus a negative 9, which is 9. And when I run those calculations, I get 163 for my answer again. Okay, I think it's worth running through this example one more time. And this time, I'm going to expand it along this row. So along the second row. So the determinant of C equals. Now because I'm using the second row, I'm going to take those numbers and I'm going to write them down. Negative 7, 3, and 2. Now I'm going to write down the determinants of those minors. So I'm going to write those in, and now I need to put the numbers in. So if I'm using this number, I cross out that row and column and I put in 0, negative 3, 4, 5. Then for the next one, since the entrance is this 3, I'm going to cross out that row and column and write down the numbers that are left. I'm going to do it one more time. This time my number is 2, so I'm going to cross out that row and column and write the numbers that are left. And now I just need to take into consideration the cofactor signs. Looking at my checkerboard, remember that this first one is a plus, which means my second row is going to be minus, then a plus, then a minus. So coming back down to my problem, I need to put a minus here, then a plus, then a minus. So now you can see here this minus and negative is going to turn into plus. So what I end up with is 7 times 0 minus a negative 12, which is 12, plus 3 times 5 minus a negative 24, that's 29, minus 2 times 1 times 4, which is 4, minus 0, which is 4. And if you add all those up together, you are going to get 163, which is what we've calculated twice before. Okay, I want to show you how this works with a 4x4 determinant. Now we can choose to expand this along any row or any column, but you would be wise to find a row or column with some zeros in it because it will make your calculations a lot easier. So let's look at what happens if we expand this along the third row. So I've got my numbers 0, 2, negative 1, and 0. And you can see my minors here. There's 4 of them that I got by taking out the row and column of each of the elements. Now notice that since I am multiplying by a 0 here and over here, that's going to make these products 0, so I don't even need to calculate those determinants. So I end up with this for my determinant. Now I do need to calculate this determinant and this determinant, so let's take a look at what those would be. Now I've got these worked out using cofactors and minors, but if you would like to, because it's a 3x3 determinant, you could use the product of the downs minus the product of the ups. But what's important here now is that I've got my 2 numbers that represent these 2 determinants. So when I come down here and I put those numbers in here and here, because this number equals negative 27 and this is negative 1. So when I take negative 2 times negative 7, I get a positive 54, and now minus a negative 1 turns into plus 1, which gives us 55.